So, hello children, with respect to this question of the assignment, coming to back to the assignment topics, you can, I have given you four, three of them you'll be doing. Yes, you'll be doing the cryptarithms one will be this, one will be this, that is eccentric artist says the best paintings, and the other is the construction of the, without using your, I mean to say, by construction, you're going to find the center of a circle using only a 60-30 set square and a pencil. So you're not using your compass here. That we also discussed in class, but I'll just give you ideas later on. For this second part, that is, an eccentric artist says that the best paintings have the same area as their perimeter. Okay, numerically. Let us not argue whether such sizes increase the viewer's appreciation. That is the aesthetic part of art, I could say. But we don't need that right now. But we are looking into what? But only try and find what sides in integers only a rectangle must have if its area and perimeter are to be equal. So let's look at it now. So the perimeter and the area have to be equal, isn't it? So first of all, you can possibly draw your rectangle. I just have my rectangle out here. By convention, the longer dimension is considered as length, the shorter one is breadth, isn't it? So, and let's say the length is, let's say, x, okay, and the breadth is, let's say, y. Okay, now we have to, all right, let's say, what's the area? It's simple, length into breadth, that is x into y. And what is perimeter? Perimeter is length of the boundary. That's 2 times length plus breadth, 2 times of x plus y. Now the constraint here is looking at paintings where the perimeter is equal to area. All right, and they're saying that such kind of paintings have the best, the best paintings are made in this format, in this framework. So again, we are not going to look into that part. Mathematically, we are going to look at this, solve this problem mathematically. So we need integer values for x and y. See, that is one thing. And the area and the perimeter are to be equal. There are only 2 such rectangles just saying. Let's find out what it is. So the constraint is what? The constraint is this. The area and the perimeter have to be equal. Yes. So that's the thing that I'm going to look at it. And the sides, that is x and y that I have represented here, they have to be only in integers. Okay. So put your constraints together. Area is equal to perimeter, and x comma y belong to the set of integers. That means set of integers. That is, of course, side can't be negative, isn't it? And it can't be 0 also. There should be some minimal dimension. So x and y will be taking values from 1, 2, 3, and so on. Positive natural numbers, rather, I could say. So area is equal to perimeter, that is xy is equal to 2 times of x plus y. So from this equation, we are going to find out values of x and y which are going to satisfy the equality and which are also going to be integers. Just move on. So one possible case is, now see, I'll just draw the rectangle again. So this would be x and y. Yes. So first of all, perimeter is equal to area, isn't it? Perimeter is equal to area. That is 2 times x plus y is equal to x into y. Area is x into y. So expanding this, 2x plus 2y is equal to xy. Or I can say 2y is equal to xy minus 2x. Or I can take out x common, x into y minus 2, 2y is equal to x into y minus 2, or 2y by y minus 2 is equal to x. So if you look here, this clearly tells me, that this, what does it tell me? That x has to be an integer and y has to be an integer, and y can't be equal to 2. Yes, why should y not be equal to 2? Because the denominator is becomes 0, isn't it? So we can come across certain inferences, conclusions, I would say. Yeah, inferences, that is, just hold on. Yeah. Inferences, isn't it? Inferences. First is perimeter is equal to area. Therefore, we arrive at this equation. These are all actually my inferences. And from this, one of the other inferences is y is not equal to 2. Since if y equal to 2 implies y minus 2 is equal to 0, so denominator becomes 0, isn't it? So one thing is the length or the breadth for that matter cannot be 0. Denominator is not equal to 0. Okay, that is y is not equal to 2. The next thing, now again I'll take it forward. 2y by y minus 2 is equal to x. So I need to draw a table for the same, and I will draw one table now. So I'm going to draw a table. Okay. So I'm going to draw a table. I'm going to draw a table and see what values of x and what values of y I can possibly put here. Okay. So um, yeah. So I'm just drawing one grid here. Okay. So okay. So I'm just drawing this table. I'll just draw some rows and some columns. Okay. So I'm just going to enter the values. So using this constraint, when this is x and this is y, what will be y? Let's say y is 1. When y is 1, what happens? I told you y and x can't be 0, isn't it? X can't be 0, y can't be 0, and y is not equal to 2 in this sense because it's obvious, isn't it? If y is equal to 2, what happens? If y is 2, denominator is 0, which is not allowed here. So the other thing is, put when y is 1, we get what? We'll check out. So I'll draw my rough working column here. So when y is 1, what happens? X is 2 into 1 by 1 minus 2, which is negative, isn't it? You're getting a negative value, 2 by minus 2. 2 by minus 1, which is negative 1. And so we're getting x is minus 1. We discard this value. And remember, we have to give only integer values. No point in me giving 1.5 or 2.5. I have to give 1, then 2, then 3, and so on. Next, y is 2 is not there, right? So from y is, I will not take y is 2. I'll take y is 3 and see what happens. So then x is equal to 2 into 3 by 3 minus 2. So x is 6 upon 1, which is 6, which is an integer, isn't it? So we can take this. So we got one value actually. One value we got. Next, I'll put y is 4 and see what happens. So x is 2 into 4 upon 4 minus 2. So that is 8 upon 4 to sa 8 upon 2. Yes. So you get 2 into y is 4, 4 minus 2. That's 8 by 2, which is 4. Yeah, 8 by 2 is 4. So this is another possibility. In this case, what happens when x is 4, y is 4? It is a square in this case. Yes, we got a square. Then put x is 5. When x is 5, see what happens. Y is when y is 5, x is 2 into 5 by 3, 10 upon 3. Yeah. So you're going to get 10 upon 3, which is not an integer. So we have to discard this value as well. So we already got two possibilities because a square is also a special type of rectangle where the length is equal to the breadth, isn't it? So we have got 6 and 3, and then 4 and 4. Yes, and this and the x and y are symmetrical. That is, my rectangle, if I rotate it, if my rectangle is like this, yeah, my rectangle is like this, isn't it? If I'm rotating it by 90, it's going to stand like this. So x and y can be interchanged in that case. It makes sense. If when y is when y is, let's say, 6, what happens when y is 6? So when y is 6, so y is 6, what happens? X is 2 into 6 by 2 minus 6 minus 2, which is 4, which is 3. Yeah. So when y is 6, y is 6. x is going to be 3. Yeah. So, I mean, these both are the identical cases I'm trying to say. That when x is 6, y is 3, and when y is 6, x is 3. So, if we can rule out this. Yeah, you don't have to try further, because if you try other numbers, you're not going to get that satisfaction. You're not going to get x becoming equal to y. Yeah, it's not going to get x become equal to y. Okay, the second approach is, I have 2 into x plus 5, perimeter is equal to x into y. So what I will do is, like, if I'm going to use cross multiplication, see what I'll do. I'll only bring 2 down here, and I'll bring xy down. So x plus y over xy is equal to 1 upon 2. Okay, and here I will split. I will say 1 upon x, the x upon xy plus y upon xy is equal to half. So this will give me 1 upon y plus 1 upon x is equal to half. So if you see, students, now I need two fractions, which I will, when I sum them up, I'm going to get an equivalent of half, isn't it? So one common sense tells me that if I have a circle and divide it into 4 parts, yeah, this is 1/4 and this is another 1/4. So 2 1/4 will give me half. That's you've already seen. That means x and y are equal to 4 each. Yes, that's another thing. So now I can also look at half in different ways. Yeah, preferably we want even numbers. So I'm going to divide this cake or the circle into 6 parts. Okay. So 1, 2, 3, 4, 5, 6. So if I take away this one sector, this is 1 out of 6. And if I take away this, I'm shading it differently. See, this together it becomes 2 out of 6. So 1 out of 6 plus 2 out of 6 is, now what have I taken out? If you look at the entire picture, like I'll just shade it for you. See, this entire thing I've taken out, isn't it? This yellow portion represents half of the full circle. So what does it imply? That means 1 by 6 plus 2 by 6 is 1 by 2. 2 by 6 is nothing but 2 ones are 2 threes are. So 1 by 6 plus 1 by 3 is half. Yes, so 1 by 6 plus 1 by 3 will also give me half. So this is another way of looking at it. We are not using trial and error. We are not using the table that we used earlier. See, we used one table, right? And when we kept on giving values to x, y rather, and then we kept on giving values to x, y, and then computing the value of x. Yeah, we had some constraints. X is not 0, y is not 0, y is not 2. So this is more like trial and error. Here we are trying to see fractions, or which two fractions will give me half. So when you compare, you get y is equal to 6 and x is equal to 3. So, or if you are written 1 by x plus 1 by y, then again it's interchangeable, isn't it? X, and because addition and multiplication are anyway, they are commutative end of the day. Okay, and then the other way of looking at it is 2 into x plus y is equal to xy, isn't it? So 2x plus 2y is equal to xy. What I can do is I'll shift everything to the 2x plus 2y minus xy is equal to 0. Yeah. Now what I can do is I can try to rewrite or I can try to simplify it in another manner. So what I can do is I can put minus 4 both sides. Yeah, I can add minus 4 to both the sides, that is LHS and RHS. My intention is simple. I'm trying to take out something common. See, across these two, again grouping technique, and these two. So 2x minus xy plus 2y minus 4 is equal to negative 4. So when you club these two, you get x into 2 minus y plus, you can take out 2 common, 2 into y minus 2 is equal to minus 4. So you can take out, you can put minus 2 common. So the y minus 2 becomes 2 minus y is equal to negative 4. Now see what happens. So you can take out 2 minus y common. It's just factorization technique. 2 minus y into x minus 2 is equal to negative 4. So you transpose the negative here. It becomes minus 2 minus y into x minus 2 is equal to plus 4. And this minus goes in and becomes y minus 2 into x minus 2 is equal to 4. See, now we can try to, so introduction of this negative 4 on both sides will help us in giving me this form where I can do a little analysis. See, now y minus 2 into x minus 2 is 4. So y minus 2 into x minus 2 is 4. See, obviously x and y are supposed to be integers. So y minus 2 and x minus 2 will also be integers, isn't it? It's closed under subtraction. Subtraction of two integers will also result in another integer. So we can write 4 as 4 into 1 is equal to 4. 1 into 4 is equal to 4. 2 into 2 is equal to 4. There's no other way I can write 4. So when you go with the first case, this is case 1, case 2, or case B, case C. Case B, we get what? Y minus 2 is 4, if you compare, and x minus 2 is 1. Yeah, x minus 2 is 1. That means y is equal to 6 and x is equal to minus 2 comes this side, it becomes 3. The second case, you get y minus 2 is 1, x minus 2 is 4. The same thing, you get y is 3 and x is 6. They're the same. They both are kind of identical cases, congruent rectangles you'll get. So, like I told you, you are just rotating it by 90 degrees. So, you can't consider them as two separate cases. The other case is when y minus 2 is equal to 2, isn't it? This 2, and x minus 2 is also equal to 2. In which case you get y is 4, and in this case you get x is 4. And this is the case of a square, rectangle becoming a square. These are the different ways of proving that, arriving at that solution. One is trial and error, the table method. The other one is the fraction method, where two fractions have to give you this half. And this is the other method, this is the algebraic method, where you use logic. So you're going to use conditions, and then you're going to solve using the linear equations. Okay, children, I hope the explanation has been helpful to you.